We are the particle physics theme. Particle physics is mainly done in SUPA in Glasgow and Edinburgh, although we do have contributions now from Strathclyde, who work more on accelerator physics, and also in Dundee, people who work on accelerator physics. And we do a wide range of different, both experimental and theoretical work. So particle physics is done a lot at CERN. So we work on many collaborations at CERN, including at the LHC. So we work on the ATLAS experiment at the LHC. People in SUPA were instrumental in discovering the Higgs boson, and a lot of us are now continuing to look at the Higgs boson. But as well as that, we are looking for new physics in the collisions at the LHC, and that includes on LHCb, where we can look at the details of the decays of the particles that come out of the LHC and see what's going on there. But it's not all LHC physics. We are also developing, increasing a program in neutrino physics, so working at various experiments around the world. Some of the focus at the moment is in Fermilab, where there are beams to produce neutrinos that we can look at short distance, but we're also building long distance experiments where we can really look at the neutrino oscillations as that. So that's it's experiment. We do also work on other searches, including for dark matter. We also do theory, so we do a lot of different phenomenology. So trying to understand from the theoretical point of view what is happening at the LHC, so we experiment and theory can come together and really understand what's going on lattice field theory. So taking the model of quantum chromodynamics and putting it on a computer and calculating what's happening. And again, we can use that and compare it with experimental data and really understand what's going down at the quantum level. And as well as that, we work on formal theory. So as an experimentalist, I might say this very badly, but trying to think about the possibilities of the way that different theories can exist mathematically consistently. And then in the future, these may become phenomenology and experiment. And again, so the whole aim is really to understand what's happening down at the quantum level of the universe. So we have a set of key courses that we recommend for students doing experimental particle physics. And these are SUPA detectors. We recommend all students take collider physics and flavor physics. Now, even if you're not a student that's going to work in flavor physics, we recommend that you take it. And again, if you work in flavor physics, if you're a neutrino-physicist, we also recommend you take collider physics, because we really believe that you should know what is going on in the field and be able to participate in discussions about them. There is a fourth course that we recommend, which has been renamed this year. It's called Presenting Your Research, and it's to develop your skills in presentations, because actually as a particle physics experiment student, you will start presenting your work pretty quickly to your collaborators. These courses are, of course, welcome if you're doing theory. If you're doing theory, then probably you need a more specialist course. So there's a couple of those that we have, but none of them are really compulsory. So you should really speak to your supervisor. But there's courses in relativistic quantum field theory and also in lattice QCD. Particle physics, by its very nature, because we're looking at so small things, which means we need really big facilities, things take a long time. So actually, your PhD will probably be part of a continuation of things that have been going on and will probably keep on going on after you leave. So in terms of the physics, it might not always sound like an advance, but the place where PhD students are really making a difference is in understanding the technology and bringing in new forms of designing detectors, of analyzing data, of understanding data. So I think a lot of the advances at the moment are in using new forms of technology, using new forms of silicon detectors and developing them, and then eventually they'll go into our experiments in the future. It is using machine learning and artificial intelligence to analyze our data, maybe also to make predictions about what we're going to do, and also in the not too distant future, starting to use quantum computing, which will feed into how well we can do theoretical calculations. So in particle physics, there's really a variety of roles that people go into. Of course, a lot of people decide to stay on in the field and become a postdoctoral researcher, but a lot of our students also go out to industry. A lot of people tend to go to things like financial services, to data analytics, which is a skill that you will really develop no matter what kind of particle physics you're doing. We've people gone off to defense industry, where they also seem to use data skills, to consulting, and also to research in the private sector. So using some of the research skills that you've got and taking that and working. And when I say research here, I mean kind of experimental research or computational research, and not so much just analyzing data, but actually kind of driving things forward for different companies. So that's the main stories that I hear back about what our PhD students have gone to do after they finish their degree. I would like new students to know that they are not alone, that there's a big community of particle physicists out there in Scotland. So hopefully you're sharing an office with someone else, but there is a network beyond that. So there will be other students in your department. There's other students in other institutions. And you probably will be working with some of these people indirectly. Please don't be afraid to ask questions. I mean, we were all stuck in the beginning. I can tell you, I'm now getting a bit older, and I'm not always au fait with the complete techniques that we use, for example, computationally. So I now ask my students how to do coding and how to put things together. So if I'm happy to ask, please, but don't be afraid to also ask your fellow students for help and advice. Because we work collaboratively, you will find that nobody knows everything about what we're doing, and you really have to ask people to find out even the essential bits for your project. So it's realize you're not alone, and please don't be afraid to ask. Even if you feel that you should know that already, you don't know it already, so it's completely fine to ask.